Math 102, example 3.4.1. So here we'd like to continue to find the zeros of a polynomial. Our last section we were given one of them to start with, but this time we're just given the function and we want to find all the zeros. So first of all, with this one, that is a cubic, so that means there are 3 zeros and I need to find all of them. To help me get started, I've got this rational zeros theorem. So this is talking about a term p over q. So if that is a zero, then p is a factor of the constant term, and q is a factor of the leading coefficient. So let's look at our polynomial. So again, p is a factor of the constant term. My constant term is 4, so 1 times 4 is 4, and 2 times 2 is 4. Now when I list these possibilities, regardless of the sign in the actual problem, I am going to list both plus and minus. Now q, that is a factor of the leading coefficient. Here my leading coefficient is just 1. If that's your leading coefficient is 1, then this list for p is also my list for p over q. So those 6 numbers are the only rational numbers that could work in this polynomial. So for example, 3 is not in that list, so 3 cannot be a zero of this polynomial. Now, at this point, I could take those numbers and guess using synthetic division to see if I get a remainder of 0. I'm not a very good guesser though, and that could take a while. So let's use our calculator to help. So there's my function, and let's graph it. So looking at that graph, I'm hopefully fairly confident that -4, because we're crossing at -4. If I check by looking at my table, you can see I've got a y-coordinate of 0, which is my calculator confirming that yes, I have a 0 at -4. So let's do synthetic division with -4. 0 times anything is 0, and I do get a remainder of 0. So that's more, again, just a check. That's what we were expecting to get. The real reason I'm doing this is to get that quotient. Again, that quotient is a quadratic, so if I set that quadratic equal to 0 and solve, that will get me my remaining zeros. You can, of course, use the quadratic formula, but I'm going to use the square root property, and let's continue it up here. That's a positive 1, and these are both minus signs, so x squared is -1. The square root of -1, that is how we defined I, and remember when we take a square root, we will get both a plus and a minus. Let's go back to our graph. We only see 1 real 0, but we know we have 3 because of the degree, so that means we expect to get some imaginary zeros. So, my zeros, again, make sure to just list all of them, are -4, positive I, and negative I. And there are all 3 of them.